Welcome to 5-3 and 5-4. Two lessons combined together to talk about the topic of multiplying and dividing rational numbers. And that is what our objective is today, is to go over how to multiply rational numbers and dividing rational numbers. Two of the topics, or two of the key terms, will be, of course, multiplicative inverses and reciprocals. These definitions are one and the same for our purpose today. Two numbers whose product is 1 are called multiplicative inverses or reciprocals. So most of the time we've called it reciprocals, but the process of finding it we're going to call multiplicative inverse. You'll see this used in directions quite often. So what is a multiplicative inverse? Well, what happens is we take a number such as 1/3 and we try to multiply it by another number such as 3/1. And if we multiply them together and the answer is 1, we have a reciprocal or a multiplicative inverse. That means that 3/1 is the inverse, or the multiplicative inverse. Now, at our first problem, we find that 2/3 times 3/4, we're going to multiply them together. After we multiply or find the product, we want to make sure that that fraction is in simplest form. All right, so some of the things we need to work out for. Well, when multiplying fractions, it's a much easier process than adding or subtracting. All we have to do is take the top and multiply them together, or the numerator. Multiply the bottoms numbers together, or the denominators. So, here we go. 2 times 3, 6. And 3 times 4 is 12. Alright, so we multiplied, which is the first step we wanted. Now let's go to the second step, simplify simplest form. Well, I noticed that 6 and 12 have a GCF of 6. That means I'm going to divide the top and the bottom by 6. And my final answer is 1/2. Alright, let's take it a little bit step further from the last slide. We're going to still multiply or find the product. And then we want to make sure our answer is in simplest form. So those are two things I'm looking out for. What's different in this one is that I'm going to take 4/7 times 1/6. And before I begin, I am going to simplify. I notice that I can take 4 and 6. I notice that before I begin the multiplication that they have a GCF of 2. That means I'm going to divide them both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Now, what I have here is I've done some work prior. So now I have 2 times 1/7 times 3. I get 2/21. Alright, now I look at that and I can say that my answer is in simplest form because I performed simplification beforehand. Not all the time is it in simplest form, but most of the time. Alright, let's continue on finding the product and putting things in simplest form. Notice that we have a negative, so we're going to deal with a negative this time, something we haven't done yet. I'm going to write it out. I notice that 12 and 3 have a GCF. That GCF is 3. I'm going to divide both of them by 3. 3 can go into 3 once. 3 can go into 12 4 times. The 5 and the 8 do not have a GCF, so I'm going to leave them alone. So now I have 5/4. And don't forget there's a negative. And then I have 1/8. So I'm going to go ahead and multiply those together. I get 5/32. And a negative times a positive is a negative. So my answer is a negative 5/32. Right, let's continue on finding the product and putting it in the simplest form. This time our change in what we're doing is that we have some mixed numbers. We're going to rename them. So we're going to rename the two. The first thing I'm going to do is say 1 2/5. Multiply the 1 and the 5 and then add the 2. So I get 7/5. After that, I'm going to go ahead and rename the 2 1/2 do the same thing again. Multiply the two numbers, then add the numerator. So 2 times 2 is 4, plus 1 is 5, and the denominator stays the same. So now I'm going to go ahead and write these out. 7/5 times 5 over 2. Do I have a GCF? Yes, I do. I only have one of them. It's the 5. 5 can go into 5, so we get 1 and 1. Let's rewrite this. So it's 7 times 1 and 1 times 2. And I notice I get 7 over 2, which is a great answer. Or, if you're asked to, you can change it back into a mixed number. And we could say to ourselves, 2 could go into 7 3 times. That gives us 6. 7 minus 6 is 1. And that's our second answer. We prefer to keep them in mixed numbers, but both answers are okay. Alright, we're multiplying again. We're finding the product, and we're going to make sure it's in simplest form. Those are the two things we're asked to do. This time we have algebraic expressions. So I have 2a over b. I can't factor those out anymore. 2 is a prime number. A is to the first power, b is to the first power. I do have b to the second, so that means that I have two b's on top, and then I just have the letter d in the denominator. I'm looking for, because I'm multiplying, anything I can cross multiply are a GCF. And I notice that b is the GCF here, so I got 1 here and 1 here. That means I can eliminate those. There's nothing else to eliminate, no more GCFs. So I'm going to go ahead and multiply the numerator, 2a times b, over 1, because that's 1 right here, times d. Go ahead and multiply all that together, 2ab over d. That, ladies and gentlemen, is our answer. Alright, we're done with multiplication. We are going to turn our attention to dividing fractions. We're going to use the two key terms. Multiplicative inverse are the reciprocal. Using the example very quickly here, we have a division problem. The first thing we're going to do is change it into a multiplication problem. We're going to look at our second number in our division problem, and that's 5 over 7. And we're going to change that and put it into its reciprocal. When we've done that, we could go ahead and go to our multiplication. 1 times 7, 7, 4 times 5 is 20. In this slide, we're going to practice our multiplicative inverse. What we're looking for is an answer of 1, and that's a positive one. So I am going to take this number. I am multiplying, because the multiplicative inverse means to multiply. I'm going to take the reciprocal of 3/8 and make it 8/3. In order to maintain a positive answer, I need two negatives, so this new fraction becomes a negative. Let me check it out. Negative 24 over negative 24, that is 1. So the multiplicative inverse for problem number A is negative 8 over 3. Our next problem is letter B. We're still trying to find the multiplicative inverse. What's different is that we have a mixed number. We're going to change it to 11 over 5, which is the same as 2 1/5. It's just the improper fraction. Multiplicative inverse reminds us that we are multiplying. Multiplicative inverse, we take the reciprocal of the number we're looking at, so that's 5 over 11. We're going to check to see if it's equal to 1. Here's something we can do real quick. 11 goes into 11 once. 5 goes into 5 once. And the end result is 1. The answer, though, is our reciprocal, 5 over 11. Alright, we're going to, according to the directions, find the quotient and make sure that our answer is in simplest form. Quotient means to divide, so we're going to take 1/3, keep that the same. We don't like division, so we change it to multiplication. We take the reciprocal of the second number, 9 over 5, And that's the first process, what we learned in the key concept a couple of slides ago. Then, since it's multiplication, we're going to go back and see if there's a GCF, or simplify before we multiply. And I notice that 3 can go into 3 once, and 3 can go into 9 3 times. Now we have 1 times 3 over 1 times 5, and that's equal to 3 over 5. By doing the GCF ahead of time, we don't have to worry about the simplest form at the end right now. Let's continue on finding the quotient, or dividing our numbers, and then making sure they're in simplest form. There we have a division problem. Once again, that's what quotient means. We take the first fraction, it stays the same. We remove the division and change it to multiplication. And 6, the reciprocal of 6, and just in case you don't know that, I'll write it over here. 6 as a fraction is 6 over 1. So its reciprocal is 1 over 6. Then I notice that, of course, I don't have a GCF. 5 and 6 don't have anything in common, and 1 and 8. So that means I got to go ahead and multiply. 5 times 1 is 5. 8 times 6 is 48. 5 and 48 do not have a GCF. So our division problem is in simplest form. Let's continue on doing quotient in simplest form. We've got an extra step here with our mixed numbers. That means we're going to rename. Okay, I renamed our mixed numbers to 15 over 2, that still remains negative, and 21 over 10, and we still have a division problem. Now let's continue on with changing our division into a multiplication. That gives us negative 15 over 2 times the reciprocal of our second, which is 10 over 21. Next, we look for the GCF. In this problem, we have something we haven't had before. We have 2 GCFs. Now, if you can see here, 2 can go into 2 once, 2 can go into 10 5 times. Then we could go ahead and do 15 and 21. We know that 3 can go into 15 5 times, and 3 can go into 21 7 times. So that gives us an answer, or a 25 over 7. And remembering we have a negative, so it's negative 25 over 7. If you're asked to make it a mixed number, the mixed number is negative 3 and 4/7. There you go. Alright, what we see here is the same type of problem. We need to find the quotient, put it in simplest form. But what we have here is algebraic expressions. What we're going to do is what we've always done, the same process. We're going to keep our first fraction, 3xy over 4. We're going to change it into multiplication. We're going to take the reciprocal. That means 8 goes on top and 2x goes on the bottom. There. We're almost done. We're going to look for a GCF for both sets of numbers. I see 4 could go into 4 once. 4 can go into 8 twice. Then I look across, and looking at my variables, don't just look at the numbers, 3 and 2, but see if there's anything you can cancel out. I notice I have an x and an x. That means I can cancel those out. I'm going to go ahead and multiply across. I have 3 times 2, and I have times y. Remember, the x was canceled out. And then on my denominator, I have 1 times 2. And let's put that together. 3 times 2 is 6. 6 times y is 6y. And 1 times 2 is 2. I'm not done yet, because I'm still looking at simplest form here. And I can see that the 6 and the 2, there's a little bit more I can do here. 6 divided by 2 is 3. And there's no y on the bottom, or in the denominator, to cancel out. So the answer is 3y.